Hi, I'm Matt Parker.
I'm Steve Mould.
I'm Helen Arney, and this is another episode of a podcast of unnecessary detail.
Which, if I'm being honest, is just a big excuse for us to talk about anything we want in any level of detail we think it deserves.
For this episode, we've picked the phrase go forth and multiply.
So I'll be talking a bit about genetics.
I'll be talking about when multiplying gets out of control.
And I'll be talking about kidney transplants.
Ooh. Well, let's go forth and multiply in detail.
I want to talk about the altruistic kidney chain. Imagine that I have two healthy kidneys. Right? You don't have to imagine, actually. I have two healthy kidneys. Oh. But imagine that my wife doesn't. She has no healthy kidneys. So she needs someone to donate a kidney to her. And of all the people in the world, who's most invested in making sure she has a kidney, a working kidney? It's
I feel like you're highly motivated.
I'm motivated for her to have a kidney, and I have a spare. So I'm the logical person to go to for the kidney, except I can't give her my kidney. And the reason I can't give her my kidney is because we've had children together. And it turns out if you've had a child with someone else, that person can't donate a kidney to you. So, Helen, Rob can't donate a kidney to you because you've had kids together. And it's all to do with your immune system. So when you have a baby growing in your womb, it's producing these proteins, as living things do. And because it has half your genes, half Rob's genes, it's producing proteins that your body produces, but it's also producing proteins that Rob's body produces because of his genes, and those ones your body isn't familiar with. And so your immune system responds, and this is the whole job of the immune system, right? It's to recognize things in your body that aren't you and get rid of them. So if a virus turns up, your immune system examines it and says, well, I don't make those proteins. That's not me, and gets rid of it. And the same thing happens during childbirth. So during pregnancy, this whole kind of immune suppression thing is going on so that the baby isn't just rejected. But at the same time, you're still building up an immune response in the same way that you do with a virus. So, if you get a virus, your body remembers those proteins so that if the virus comes along again, your body attacks quickly and aggressively. And so after your child is born, your body now knows about these proteins. It's developed an immune response to those proteins. And so if Rob tries to donate a kidney to you, your body will reject it as if it's a virus it's come across before.
So you've been inoculated against your own partner.
That's exactly right. You have
Wow.
an immune
That's
response
incredible.
to Rob now. And Leanne has
That's
an immune
insane.
response to me.
I mean, we all know Leanne has a response to you, Steve. I didn't know it was immune.
Yeah.
One of my friends used to call their unborn child the parasite because it being pregnant made her so sick. And part of that concept is kind of true, that it may not have been related to her feeling so awful for her entire pregnancy, but she was building up an immune response to the invader inside her body that had half its genetic material from someone else.
Yeah.
Wow.
Yeah. I mean, it's also sapping resources and stuff like that. But yeah, I like the placenta. Part of the job of the placenta is to be super sneaky, to avoid the immune system.
A cloaking device.
Yeah.
I've never thought of a placenta as like some kind of stealth, undetectable, like a secret agent.
It's the nothing to
But
see
now
here.
I do.
So, is there a solution? And the solution is actually a mathematical solution. So I want to give Leanne one of my kidneys, and I can't. So maybe instead I could sell my kidney, get a bunch of money, and use that money to buy a kidney that is compatible with Leanne.
Like
Right?
we
That's
always
not
say
maths.
Solution.
here, capitalism to the rescue. That's
Capitalism to the rest.
That's our motto.
That's not maths, that's economics, and it also sounds like bad maths and bad economics. Like,
Yeah, because as a
Bad idea,
society,
bad.
we've decided that we don't want to buy and sell organs, right? We're not comfortable with that as a society, and that seems fair to me as well. So instead, we have to do this altruistic thing. There's a program in the UK called the UK Living Kidney Sharing Scheme. And the idea is that I have a kidney that I want to give to my wife, but I can't. Someone else has a kidney that they want to give to their wife. They can't. But it turns out that my kidney is compatible with her and his kidney is compatible with Leanne's. So we do this little swap. And, yeah. So that's called a paired donation. But often it's quite difficult to find someone who not only is willing to give a kidney because they have a loved one in need, but who also happens to match in terms of all the other antibodies that are going on in the immune system. So you end up with these chains of people, and this is where the maths comes in. You've got this complicated network of people trying to donate kidneys. Often it ends up in this sort of stalemate. You can see all these links, but there's no one to start the chain. And so this is where the altruistic donor chain comes in, or the altruistic kidney chain. So you have one person who's just like, this isn't for anyone. I just recognize that I have a spare kidney. I'm really healthy. Let's just give it away. And they look at where this might work in their sort of database, their network of nodes, and say, okay, if you put the kidney in there, then that person's loved one can donate their kidney to this person, and then that person's loved one can donate their kidney to this person, and it's like a domino effect. So you have this one altruistic donor that creates this domino of donations.
that is one of the most heartwarming things, or kidney warming
That's a different
things
network.
that I have
Yeah.
ever heard on this podcast or anywhere else. Humans are extraordinary.
Yeah, and it's a technological marvel really as well. The manipulation of data, the collection of data, because it's all this stuff about if you needed a kidney, for example, doctors would have to analyze your immune system. What antibodies do you have? And then they'd have to look at the donor and look at what antigens does the donor produce. It's like blood type and things like that.
It's definitely, this is what computers were for, because
Yeah,
Yeah.
totally.
probably by eye you could do a few matches here and there if you had all the people on like a pin-up board with bits of string.
With red ribbon between them.
Exactly, yeah.
Imagine you get the door knocked down by the police and you've just got red ribbon connecting people.
Connecting
what are you
people's
doing?
kidneys.
Oh, I'm moving organs around. It's fine.
But the computer can just crunch it. I mean, thanks to hardworking mathematicians the world over,
Yeah.
the graph theory is reasonably well understood, and you can be implemented to do a search. Still has to be clever, I imagine, because the number of combinations possible must be like you couldn't just check them all. You still need some clever mathematics and algorithms, like a traveling surgeon's problem, to be able to go through.
Yeah, I was just going to say traveling salesman, but obviously traveling surgeon is a slightly better joke.
Thank you.
What this reminds me of is like buying a house in a chain.
Yeah.
I was
But-
about to say, for non-UK people, when you buy a house in the UK, this is ridiculous. It's not like you sign a contract in advance and work it all out. No, on the same day, everyone's got all their stuff in a moving van, and you as far as I'm aware, you physically pass keys down the chain, and everyone moves simultaneously. Correct me if I'm wrong.
Yeah. Well, you kind of end up in a chain where someone wants your house, but you haven't really sold it to them because the people you're trying to buy a house from haven't really sold it to you yet. And that it continues
It's
for
ridiculous.
however many in the chain. And then kind of all at the same time, you all have to coordinate.
It's because the laws were written in probably the 1600s on how to do home ownership transfer.
When you were literally like, hey, come and move into my wooden shack and I shall move into this clay shack.
Yeah.
And the person in the clay shack shall move into the mansion.
This is a
it was
massive
different
tangent,
world.
but I don't see any other way to do it, Matt. Like, I can't buy a house until I've sold a house.
Yeah, but you can.
I mean, in Australia, do you have banks just like bankrolling the intermediate step?
No, you're contractually obliged. You can't pull out past a certain point. So in the UK, at any point, you can change your mind and gazump or gazunder or do all these ridiculous things until you physically have lawyers moving the money at the same time keys are physically moving. Whereas in other countries, you've just got a contract that says you've paid a deposit. It's happening.
Right.
And then that way you haven't got this dance on the day.
You need an altruistic renter who's just going to sell their house and move into a flat share for a bit.
If we're talking kidneys, they don't all have to sign on the same day and like pop into the hospital on the same day, right?
I don't believe so, no.
Once it's agreed.
Here's the keys to my kidney. I mean, I've just moved house and I'm not a fan of the whole system here.
Oh, it's not good.
So, Steve, would you rather sell a house or a kidney?
Honestly, at this stage, a kidney, I think.
Yeah,
I agree.
Probably would too.
Totally.
Yeah. I'm going to start with a question. This question is, what do you do when you get asked to do your first gig after a national lockdown in the UK? And that gig is entertaining several hundred world-leading, groundbreaking geneticists at a high-profile industry awards ceremony. Any ideas?
I mean, that is a very specific hypothetical.
It
Yes, it happened. And what I did was I completely freaked out. I was asked to do this amazing award ceremony with all these geneticists. The thing is, right, I know what to do if I'm faced with a room full of chemists, right? I sing Tom Lehrer's Elements. Yeah,
Yes,
we all know this because you heard it in series 1. And I know what to do when I'm faced with a room full of physicists. And I do Tom Lehrer's Elements. It's completely obvious, right? But geneticists are completely outside of my bag. I had a brainwave. This brainwave was actually helped by my sister, Dr. Kasani, who is both a geneticist and genetically related to me.
Yeah.
Yes.
And also I got some help from Sally LePage, Dr. Sally LePage, who you know, whose entire PhD was studying fruit flies. And with their help, I came up with Tom Lehrer's Elements. Yes.
Yeah.
Absolutely
Wow.
right. Okay, but I replaced all of the elements with genuine, bona fide, actual, in current usage, fruit fly gene names.
Oh, nice.
I mean, I know we're all niche comedians here, but Helen.
How long is this song compared to the Elements song, the original? How many fruit fly genes are there?
I did it half length, and it's got a large number of fruit fly genes.
Okay.
Like about 50. It's a lot.
Okay.
And I had to get a geneticist at the Wellcome Genome Campus to check them in case I had made a horrible mistake.
So you can
and it was
pronounce
fine.
all these ridiculous genes.
Yeah, ridiculous gene names.
I guess
Right?
I'm confused because isn't it just you singing like B62912 712? Do you know what I mean?
It's not the chemical structure.
I see.
It's not radio
CGDT.
crystallography, the song. Yeah.
Fruit fly gene names have the widest range of absolutely bizarre names. Putting them all together, I came up with a song that was, and I'm going to use this word entirely with fruit flies in mind, absolutely bananas, right? This song is completely bananas.
They do love bananas.
And they're genetically related to bananas by about 60% or something.
It's 100%, not just 60%. It's 100. It's 110% bananas.
Now you're just upsetting everyone.
The question I have is, would you like to hear it?
Yes.
110% yes.
La 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 la. There's Cleopatra, Capulet, Cap and Collar, Chickadee, Breathless, Bric-a-Brac, Harry, Ken and Barbie, Jelly Belly, Swiss Cheese, Genghis Khan and Gooseberry, Sloppy Paired, Slowpoke, Slipper Slouch and Say Yippee, Prospero and Pangolin, Pavarotti, Pigerpuss, Crocodile, Clutie, Dumpling, Currant, Bun and Comfort, Sex, Lethal Saxophone, Son and Bride of Sevenless, Brainiac, Amnesiac, Giant, Runt and Tailless, la 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 la. There's Double Part, Deadpan, Dax, Hunt and Dodo, Mastermind, Menage a Trois, Nautilus and Nemo, Hopscotch, Hunchback, Highwire, Hedgehog, Homeless, Hamlet and Hippo, Tubby, Tin Man, Take-Out T-Shirt, Tolkien, Tango, Torpedo, la 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 la. A fruit fly's DNA has lots of code that is just dross or filler. But these genes and some others are what make it a Drosophila. La 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 la.
Very good.
Thank you very much.
I mean, the Drosophila, that's...
Drosophila.
It's memorable, right?
Honestly.
I have some follow-on questions.
Me too.
I bet you do.
Hairy Ken and Barbie, is that 1 or 2 genes?
It's nice that you asked that because it's hairy is one fruit fly gene, and Ken and Barbie is another one. And the Ken and Barbie one is because the fruit flies come out blonde with no external genitals.
Oh my goodness.
So, right, fruit fly people are really fun at parties. And the thing is, I did all of this research, this crazy amount of research for this song about how genes got their names, what they do, all the names that have caused controversy over the years, and how much of it went into the song?
0?
Like nothing.
Yeah.
None.
Because the song just gives you a load of questions about fruit fly
So many
genes.
questions.
So here we are. This is 100% pure, unadulterated, unnecessary detail that I'm going to go into now. What else is this podcast for if it is not for me to use the research that I did for this song that contains no research? I'm going to ask you in a second for your favourite fruit fly genes from the song that you want to know more about, which is probably going to be all of them, but we'll see how much time we have. But before that, I wanted to go into, like you say, like, why do they have these bizarre names? There's lots of different geneticists, right? Fruit fly people, zebrafish people, mouse people, human people. They're all like different species of geneticists. The fruit fly people were the first with the naming because fruit flies are incredibly useful, and they kicked off the whole research of genetics, and they are still incredibly useful. They've received at least 5 Nobel Prizes. I assume they were given to the flies rather than the people who did the research. I'll never know. It's because fruit flies, they breed very quickly. They breed very easily. They're kind of simple. They've only got 4 chromosomes, but one of them's an X and one of them's a Y, which is very similar to humans. So they're super complicated because they go from an egg to a larvae to a fly, and it's a really complex life cycle, but they're also quite easy to understand compared to humans. And they've got a lot of gene mutations that show up with something really obvious that you can see with the naked eye or with a microscope, or you can detect quite easily. So I'm not really overstating when I say that genetics would not be where it is today without the humble fruit fly. Although I doubt the fruit fly is actually very humble.
Not with 5 Nobel Prizes, they're not.
So the first fruit fly gene name happened in around 1910, which is before genes were actually universally accepted as an idea anyway. Side fact, the first gene name was given by Thomas Hunt Morgan, who was the great-grandson of Francis Scott Key, composer of the US anthem, The Star-Spangled Banner.
Wow.
Weave that into conversation. The conversation could be about anthems or genes, and bam, that fact.
You got it. It's in your back pocket now. Roll it out whenever you like. So Thomas Hunt Morgan discovered that some male flies had white eyes instead of red eyes, and he called this like weird thing, he called it white, which ended up as the name of the gene. And he worked out that it was on one of the sex genes, it was on the X chromosome, and he basically discovered sex-linked genes. Like insane, before genes were accepted as a thing that actually happened, right? So at the time, they had scrupulously boring names for all of these genes because they didn't have very many of them. And they were mostly named after the effect that came out on the fly, like what the fly looked like when this gene was messed up. So it was kind of easy, right? And then in the 1980s, fly scientists ended up having an explosion in productivity, all of these new techniques and stuff, and they had hundreds and hundreds and hundreds of genes to name, and they couldn't name them after something obvious anymore because a lot of the mutations kind of look the same, and they had to get more creative. And also, I have to point out, these people have spent literally years sifting through thousands of unconscious flies every single day to find mutations, and finally they found one and they have a chance to name it. Give them a break.
Fair enough.
Let them call it something ludicrous. They need a bit of a lift at that point. That's all I'm saying.
I don't know. Every other scientific discipline, like mathematicians, we've got a system. for naming numbers.
Yep.
You name the number, job done. Chemistry, I mean, it's boring, but they got a system.
Yep.
And then the fruit fly people are just like, nah, there's no bounds. In fact, if you name it something boring, you'll be shunned.
We will go into that in a little bit more detail because, like all things, it's a little bit more complicated than that. But I wanted to know, which genes would you like to know more about? Steve?
Well, the one, I don't know why this stuck in my mind, but Tin Man.
Tin Man is named because it's an important gene in developing the heart. And when it's mutated, which is often how these genes are named, they're named after what happens when the gene is mutated or missing or damaged or doesn't do what it's supposed to do. When the Tin Man gene is mutated, the fly has no heart. So it's named after Tin Man from Wizard of Oz.
Amazing.
So fun at parties. Matt, do you have one?
I think, I'm just going to work through them in order. So you opened with Cleopatra.
Yes.
So I assume that's the gene where you end up in a civil war with siblings in the dying years of a empire.
Close. Cleopatra, famously, at the end of her empire, she committed suicide by allowing an asp, a type of snake, poisonous snake, to bite her on the boob. And this gene, when it's mutated, it doesn't actually do anything to the fly. It doesn't cause any problems, doesn't cause any damage.
It attracts
until it comes into contact with the ASP protein, the ASP protein.
No.
I'm not kidding. I am not kidding. It's like a Shakespeare play right here. It's incredible.
And that is really imaginative naming. I think that's really good.
Second order name.
Yeah.
Tip of the iceberg, guys. So if you're doing the Hamlet one, Hamlet is in the song. The Hamlet gene affects the development of cells. This cell affects the 2B progenitor cells. It's written down like IIB, so it's not obvious at the beginning, right? If it's mutated, the 2B doesn't happen. If it's fine, the 2B does. So it's 2B or not 2B, Hamlet. There you go. I'll take no further questions about this gene. By the way, don't ask me how they work or what they do. I just know how they're named. That's all I've got. I'm a physicist. That's my limits. Anything else? Lindsay, our wonderful producer, Lindsay. What would you like to know about?
Okay, I've got Lindsay, our producer, in my ear. And she just shouted sex lethal, which is mildly concerning. And what was the second? Lindsay, what was the next two? And then just syllables. I don't think they were real words. Clump fuss and Cluty dumpling.
These are three good ones.
I think she's messing with me. I don't remember.
No. These are all in the song. Sex lethal, that is a master switch gene. So that determines sex in fruit flies. So if it's activated, the fruit fly becomes female. If it's inactive, then the fruit fly becomes male. It's an unbelievably important gene. The thing is, if it gets messed up in a different kind of version of the gene, it becomes lethal in males.
They've gone for a literal one there. That's a little
That's
say
less
what you
creative
see.
than the other ones, yeah.
Yeah, but it is very explanatory. And, it's useful if that gene pops up in other animals. It's kind of handy. Klumpfuss is a good one because this German-American team of Nobel Prize-winning geneticists, they're responsible for a whole load of names. And they studied, not fruit flies, they studied fruit fly maggots, which is absolutely rancid. So they deserve to name as many of them as they like in whatever they like. And a lot of them, they chose German words because a lot of the words have been English so far. And they wanted to challenge the English-speaking world by making everyone learn a whole bunch of German words. So they picked a load of words in German like Nerps, which means little one. So those maggots were quite small. Spätzle, which is a type of stodgy dumpling. I have no idea what those maggots look like. Probably stodgy dumplings. And Klumpfuss means clubfoot. Matt, what was the last one?
And Cluty dumpling, I think.
Cluty dumpling. Yeah, Cluty dumpling. This is, I love this. This leads you into the whole world of like groups of fruit fly names. So there's a whole bunch named after British desserts. So Cluty dumpling, apparently a British dessert. No. It's not from around here, but anyway. Currant bun was in the song as well. Also Spotted Dick, couldn't get it in the song. Sorry about that.
Probably for the best.
There's so many groups. There's a whole group of unfortunate fates commonly met by eggs, which are the names for defects in the kind of egg part of the fruit fly cycle. So they have names like fried, omelette, sunny side up, hard boiled, soft boiled, poached,
Easy
and
over.
Benedict. Benedict, which is also a Shakespearean character. So it all comes full circle. Also, oh my gosh, if you think fruit fly scientists are fun at parties, you haven't met zebrafish blood cell scientists. Seriously. There's two types of blood cells, right? Red cells and white cells. They've named the genes on those different types of blood cell after different red and white wines.
Oh my
Of course
gosh.
they have.
And if someone discovers a new red or white cell, like there's one particular lab that if they discover a new type of gene on a red cell, they can name it after a really expensive wine, and their supervisor will buy them a bottle of incredibly expensive wine.
Nice.
I'm surprised they're not getting sponsorship deals with wineries. Like, hey,
Yes, I mean, most of them are like called Shiraz or Chardonnay or something. Like, all I want from life is to be a fruit fly on the wall when someone discovers Chateau Neuf de Pape, the gene. Right? If that's happened already, I want to know what happened. If it hasn't happened, I'm waiting. I need to know. All right. So,
I can imagine some poor researcher going, come on. It's box of. Oh.
That's the Australian researcher, isn't it?
The Aussie one. Oh,
Yeah.
man. I got a box
Oh
of.
man, box of Blue Nun. That's it. Great. So sometimes a researcher or a team of researchers will pick like a quirky topic. And it's not just the fruit fly geneticists, all the other type of geneticists are getting in on this. And there's a lot of those sets that have incredible unnecessary detail inside them that you wouldn't know from looking at it. So there's the hedgehog group, which is the hedgehog signaling pathway. There's loads and loads of genes involved in this. And the first one they discovered, the mutation makes the larvae of the fly look really spiky. And it's part of this bigger picture about how information gets transmitted in a growing cell. And it's also been discovered in vertebrates as well. So humans, mice, we all have hedgehog signaling pathways, and that's how it's known. And the first three they found were named after real hedgehogs, like Indian hedgehog, moonrat hedgehog, desert hedgehog, standard hedgehogs. And then they ran out of hedgehogs. So they started naming them like, I don't know, like groundhog, quahog, warthog, like whatever. They're not even hedgehogs. And then they started getting really whimsical and just went for Tiggywinkle and, famously, Sonic Hedgehog. So Sonic Hedgehog is a super famous gene.
Super famous hedgehog.
Super famous hedgehog, super famous gene. There's some sets of genes that tell a kind of subtle story about how the gene functions and how it got its name, like a whole set of unsuccessful polar explorers. So if you've ever wondered why there's a gene called Scott of the Antarctic, it's because if this particular gene is mutated, it can't send the right signals to develop a head at one end of the embryo and a tail at the other. So basically it can't find its head from its tail. It's lost at the two extreme ends of the embryo, like an unsuccessful polar explorer, right? You get what I'm saying?
That's a real burn for poor Scott.
Yeah, it's harsh. And it's also like quite sad. There's one called Frankel, which is named after someone who was part of a team who got lost going to the North Pole by hot air balloon, and the whole team died, right? So it's kind of fun, but also like a bit sick. And it's not something you would introduce like to your mum after a first date, which to me sounds like a lot of geneticists that I know as well. Right, this one is amazing. This has 2 layers. There's a whole set of genes named after Italian trains because the chromosomes resemble little trains. They've got like little kind of lumpy bits that meet in the middle, so they look like a nice little set of trains with all the carriages and stuff. It's lovely. So they're named things like Caravaggio, which is a type of electric train that you find on the Italian rail system, and they're also called Verrocchio and Modigliani and things like that, which might sound familiar because they are also Italian artists, right? But these genes haven't been named after Italian artists. They've been named after Italian trains, which in turn have been named after Italian artists. So these genes are named after Italian artists through the medium of them being named after Italian trains.
If I ever need a pseudonym when I'm doing art, I'm going to name myself after one of those genes. that's named after a train that's named after an art. I mean, come on.
There's layers and layers. Layers and layers and layers. Okay, my favourite one, extreme lengths that people have gone to get names for their fruit fly genes. Tim Tully wins the award for this by not only naming dozens of genes after Pavlov's dogs, but also going to Russia to find out the names of Pavlov's dogs because they aren't actually commonly known. Tully's first scientific achievement was developing a Pavlovian learning task for fruit flies.
Wow.
I mean, I don't even know how you do that, right? That's already beyond my abilities.
Very small bell.
Like, yeah, a really tiny bell.
Tiny bell.
How do you do it? Right. So he found all these genes, and they're all to do with memory and learning, and he wanted to pay tribute to Pavlov because he knew that Pavlov had a lot of dogs. But only one is well known, and that's Birka, which means white. We've already established that the gene white has been taken. That was the first gene, so you can't use that. So he went to Pavlov's home. He managed to get someone to show him round the place where Pavlov used to live. And at the end of the tour, he asked really nicely, and they showed him all like these old photo books of pictures of Pavlov's dogs with all the dog names that weren't common knowledge at all. So there's some called Jerka and Jack and Marker and Joy and all of those ones. That is 100% serious commitment to detail.
And it's really nice now that we know those names, you know.
Yes, this is not just named some interesting fruit fly genes that relate to memory and learning. We have discovered some unnecessary detail about the names of Pavlov's dogs.
Cool.
There are some gene names that are very much not cool anymore. And no one is suggesting that we bin every single fun gene name and replace it with a string of letters, which would, of course, be Matt's preference. We're not going to do that.
Alphanumeric.
Yeah, I know you'd like to, but it's not going to happen. Because it is actually quite helpful to have memorable gene names for researchers and for people communicating their science. Because if these same genes appear in different species and the name is memorable, it kind of helps trigger off knowledge about what they do. And it can be a shortcut to understanding and a shortcut to this demonstration of evolution across the species, right? Same gene, same function, amazing. Evolution is incredible, but it can also be a distraction if the gene doesn't actually do the same thing in different species. So it's like, it's got good and bad bits. There are some gene names that have fallen out of favour, and I think it's quite obvious because they make me feel a bit uncomfortable. Like cheap date is one where the flies have a poor tolerance to ethanol, which is alcohol.
Right.
So they're called cheap date. Yeah, I'm not going to use that one anymore. Lunatic fringe. It's about forming the edges of a fly's wings, and this appears in mammals as well. And you also get manic fringe, radical fringe, and lunatic fringe. The problem is this one features in some quite serious human genetic disorders. So if you're like, trying to explain to a patient or a family that someone they know has got like a very serious disease, you kind of don't want it to be called the My Drunk Uncle Jeff gene or like Sparkly Wonder Bra or something really whimsical. So there is a reason to rename them for being inappropriate. There's also a reason to rename them for legal reasons. There was a Pokemon gene, but it's now called ZBTB7 after apparently Pokemon USA threatened a lawsuit over trademark. So
That's
bad.
ridiculous.
Yeah, but I mean, when it's implicated in certain types of cancer, you're like, I kind of don't want my Pokemon game to be implicated in that way. So I kind of see their point.
And you don't want to catch them all.
Yeah, you really, you really don't want to catch them all that way. So how do human genes get renamed is a good question. And there is the Human Genome Organization Gene Nomenclature Committee for that. Right? I don't know what committee was in charge of naming that committee, but they need to take a good hard look at themselves. They're in charge of the naming system. The naming system, Matt, that you want, it does exist for human genes.
Yep.
Because
nice and boring.
It's got to be a bit duller for the reasons we've mentioned. And they're also responsible for renaming them. And the thing is, right, they're kind of okay with the Sonic Hedgehog gene. They're kind of all right with that because it's not particularly, like, pejorative or offensive.
Yeah,
and
I'd be okay with that.
They get that it's fun and people have heard of it. And it kind of plays well when people hear about it in the media and it makes them curious. But they have changed Lunatic Fringe. Lunatic Fringe is now known as LNFG officially, and that's pretty much what it's called now. But you're still allowed Sonic Hedgehog.
I actually recognize the name of that committee because last year they renamed human genes to make them less susceptible to autocorrect mistakes in Excel.
No.
Yeah, because a bunch of the names for human ones are good systematic. They're like SEP15. But Excel sees that and goes, oh, well, that's September 2015. And it autocorrects. And you wouldn't believe how many biologists use Excel to sort their data.
Wow.
And you don't have to believe it because someone did some research. It's about 19% of all genetics research. They sampled a decade worth of research. 19.6% of research papers had data attached with an autocorrect error in it. And the easiest fix was to rename the genes to avoid the problem. I mean, I've come full circle. If they'd called them Sonic the Hedgehog, if they were all named after video game characters and whatnot, we wouldn't have had this problem. So, I kind of, yeah.
Those fruit fly scientists were right first time.
I hate to admit it. Yep.
This episode is sponsored by Brilliant.org, where you can learn science and maths in the best way possible through interactive lessons. If you're listening to this podcast, you're probably a bit like me and you like to research stuff for yourself and not just take people's word for it. Brilliant has so many great courses that help me to make sense of the world. So if you prefer to understand all the numbers that appear in the news for yourself, the course Statistics Fundamentals is there for you. And if you want to sort the reality from the hype around cryptocurrency, there's a course on that too. The lessons don't just look great. Everything is broken down into logical steps with examples that you do for yourself rather than just reading about it or watching a video. And it's there for you anytime on your desktop or on the app if you want to do something other than doom scrolling on your phone. You can get started for free, and if you decide you want to sign up for an annual membership, the first 200 unnecessary detail listeners will get 20% off. Follow the links in the show notes or visit our special URL at brilliant.org/APOUD.
I would like to talk about the world's most expensive, not one-of-a-kind book. It's the most expensive retail book. And it was listed at $23,698,655.93 plus $3.99 shipping and handling on Amazon.
What do you mean? There were thousands of these? Like any sort of novel, there were loads of them?
Yeah. I'm ruling out the, Bill Gates paid over $30 million to buy one of Da Vinci's notebooks. Right. So if I just said most expensive book, someone would be like, well, actually, technically, people paid a lot of money for special editions and all these things.
Right,
no, this is just your run-of-the-mill production book. In fact, there were 2 copies available, both for over $23 million.
Oh, my goodness.
Now, I bought I own a copy of this book now. I bought it as part of my research.
Matt, how much are you earning from this podcast?
Yeah, I know. Yeah. I'm making podcast money now, I thought. So I can invest in the most expensive book. No, I got it at a 99.999943% discount. And so I've actually I paid about 10 quid.
This reminds me of the Officers Club where everything's way too expensive but has everything 75% off.
Yeah. It's just always a massive... It was a mistake to be listed at that price. And it involves multiplying, which is why I've brought it up. However, it was genuinely and earnestly listed at that price with no discounts. And if you had put your card details in and paid the $23.698 million plus $3.99 shipping and handling, it would have been sent out to you. So it wasn't a joke listing. It was absolutely serious and disturbingly on theme. I've got the book here. It's all about fruit fly genetics.
No, you're kidding.
Yeah, there it is. The Making of a Fly. The Genetics of Animal Design. 99.999423% off.
So if I had called you, you would have You would have been able to help me.
I probably could have given you a hand. I could have looked some of those ones up in the index here.
So annoying.
Cleopatra is not in the index.
Oh.
And this book is, like, legitimately a staple. Like, this is owned by a lot of labs that do fruit fly research. This is, a real used textbook. But not like just a textbook that you make undergrads buy because you're a co-author. Like a legitimate bit of like academic textbook. For the record, it should have retailed for on the order of $100, which is still...
Oh, yeah. Okay, that's
still a lot, but
cheap.
for a reference book, okay, it's not so bad. And one day, some researchers at the University of California at Berkeley, who do a lot of research on fruit flies, they're like, oh, we need another copy of this for the lab. And so they jumped onto Amazon because this book came out in 1992. It's out of print, but there are still loads of secondhand copies kicking around. So they just fired up Amazon, found a secondhand copy, and realized it was listed for over $1.7 million. Like, what? And then they're like, no, wait. There's 2 copies, and the other one's listed for $2.198 million. What on earth is going on? And they're like, that's
What's
weird.
the difference between those two numbers?
Good question. So one was 27 and a bit % more than the other.
Okay.
Which is about to become very relevant because the next day they changed. So the lower one jumped back up to be just below the higher one. And then the higher one jumped up again. And they returned to the same ratio of just over 27%. So these researchers were like, forget our fly research. They got a spreadsheet and started recording how much each one cost on each day. And they eventually worked out these 2 ratios that the prices were flipping between. And it turns out on Amazon, you can set your pricing algorithmically. So one of the 2 sellers had written a function which was something like, I've got a copy of this book. I want to sell it. I want to be slightly cheaper than the current cheapest copy because I just want to shift this thing. I want to get the next sale. And they set their algorithm to look on Amazon, find the cheapest copy, and set theirs at like 0.17% less. The algorithm is something like find the current price, work out 99.83% of that price, and that's what you set this copy at.
That sounds entirely sensible.
Entirely sensible.
That does sound like a good system.
And you won't be far below it. You'd be like, a tiny bit cheaper, but some people just go on, buy the cheapest copy. Job done. Mm-hmm. Someone else, however, had an algorithm which would go on, find the cheapest copy, and set their copy to be 27% more expensive. And you think, well, that's weird. Why would you want to be more expensive? And the theory is that this seller didn't actually have a copy, but they've got a very good track record and very good reviews and lots of stars. And risk-adverse shoppers would pay more to go with the higher reviewed and ranked seller. So they were basically, leveraging their good track record to advertise books they didn't own yet, ironically, having a good track record. And then they figured 27% above normal asking price was enough for them to go and source the book and then ship it.
So if this was a £10 book, the cheaper one, say that had ended up at £10, the more expensive one would only be £12.70 plus postage and packing, which I'm like, if it had 5 stars, it promised to get it to me within a reasonable amount of time, I would consider buying the more expensive one. Totally. And so I don't risk getting ripped off on Amazon.
Exactly. Yeah.
It's a good system.
And if there had been a third seller, like you say, Helen, who lists it for £10, the first seller would have set their price at £9.98. The second seller would have listed their price at £12.70. And all would have been well for the world. There would have been 3 copies on there. But let's say that happened and then someone bought the middle copy, the £10 copy. Suddenly, the cheapest book is like, oh, we're no longer 0.17% below the cheapest one. We're way below it. So their algorithm would jump their price right up to be just below the other one. But the other one's like, wait a minute, I'm not 27% above
I've
the
just
other one.
worked out what's
And they
happened.
would increase.
I've just worked it out. I'm so slow.
And then the first one's like, wait a minute, how'd they get up there? And then they'd increase. And the maths of it is 1.27 times 0.9983 is bigger than 1.
Yes.
And so each cycle ratchets it up.
Oh my gosh.
And like all good lazy programmers, they hadn't dealt with edge cases. And so there mustn't have been a upper threshold or any kind of human intervention in the system, and it just raced away.
I feel like this is like sweet vengeance for every time you two on this podcast or in real life or in any of our shows have gone like, programming, it saves the world, programming, it's so great, programming, yay! And everyone else who's like, I don't know how to program has been going, eh.
For every desperately needed kidney, there's a algorithmically priced book.
It's £1 million book.
And this is what we base our entire financial markets on now. Algorithmic trading. So that can't ever go wrong. Yeah. I mean, keep a human in the system is the advice here. Or have just thought through and like have some sense check limits like on your code. If your code's doing anything of consequence, define the boundary outside of which it needs to stop doing what it's doing and fail safe, not $23 million book.
Presumably the more likely thing is that two companies selling on Amazon will try to be a bit lower than the cheapest option. I imagine that might have happened quite a bit, and so you end up with things just being essentially free. Are you aware of that happening?
Cheaper. No, I have not come across that. I think either stuff gets
you could have many people selling it, and it would just be the bottom two that race to the bottom.
Yeah, but those will get picked off very quickly.
People would buy those copies.
They'll get
Oh,
bought.
that's a very good point.
There's like an escape velocity going up.
If they exist as well. The problem is there was only one book and one company was just going to go and buy it from the other one for £12 million minus 27% or whatever it was. The book didn't exist, Steve. It didn't exist.
I just think, people would buy the cheap ones before it spirals out of control.
Yeah,
and the
that's
expensive one just... And it was just that perfect storm of the feedback loop between those two algorithms, the fact that there weren't any other sellers at that time shifting the book, and that no one was paying... It was an obscure enough book, no one was paying attention to it. I mean, it did fix itself, quote unquote, one day. First one to crack was cheap algorithm. So either they noticed, because they're the ones we think actually had a copy of the book, so they're like, why isn't this book sold? Or when they were coding it, they did say, if the price goes above $23 million, reset. I don't know. But that someone noticed, they dropped it back down to $106.23, and then the expensive one fell into alignment the next cycle.
Right.
And then, so because...
And the researchers went back to counting flies.
Yeah, they bought their copy.
Oh.
And so that was algorithms multiplying prices. Yeah, on a book about genetics. I've never been so on theme in my life.
I can vouch for that.
So it's time to wrap up this episode before it multiplies out of control.
Thank you so much for listening, and thanks to Acast for making us creators part of the Acast Creator Network.
And don't forget to check out the show notes for loads of extra detail. They're also available at festivalofthespokennerd.com/podcast.
And however you can, please do spread the nerd about this podcast, because the more people listen to it, the more of these we can make. And we will. Don't test us.
It does sound like a threat.
It's definitely a threat.
We make other stuff as Festival of the Spoken Nerd. We've recorded 3 big spangly science comedy live specials. You can download them for £3.14 each from festivalofthespokennerd.com/shop, or the usual places like iTunes, Amazon, Google Play, all that
You
stuff.
can also get all of our other stuff like books, t-shirts, radio series, and free songs from the website too. There's even the theme music from this podcast. It's a good theme music. You should go and get it.
Until next time, goodbye.
Bye. Bye.
A podcast of unnecessary detail is made by Festival of the Spoken Nerd. That's Helen Arney, Steve Mould, and Matt Parker. Our series producer is Lindsay Fenner, who also produced this episode. Our theme music is by Howard Carter, and we are proud to be part of the Acast Creator Network. Thanks for listening.